So next come to performance of pipelining processor. To calculating the performance of a pipelining processor, we have some parameters are there. So these are what? Speed up ratio, frequency, throughput, and efficiency of the pipelining. Okay, so before discussing all about the parameters, just have a look to this diagram. Assume that we have 5 segment or 5 stages are there in pipelining, and we have 6 instruction. How many instruction is there? 6 instruction. To execute the 6 instruction, how many clock cycle we need? Assume, look here, how many clock cycle? 10 clock cycle will need. So how it will become 10? Now 5 here number of instruction are what? 6, and number of stage or phases or segments are equal to 5. So 5 plus 6 minus 1 equal to 10. So you can say k plus n minus 1 time is required, or k plus n minus 1 cycle will be required to complete a pipelining process. Okay, so how many instruction is there? 6 instruction is there. So when we will insert the first instruction into stage 1, after complete his operation in stage 1, he will move to stage 2. So like that it will continue up to stage 5. Okay, so look, when instruction 1 complete his task in stage 1, he will jump to stage 2. At that time, when the stage 1 when the instruction 1 is executing in stage 2, stage 1 is blank. So at that time we can also put another instruction into stage 1. Okay, here we put instruction 2 into stage 1. Similarly, when the instruction 1 complete the task in stage 2, you will jump to stage 3. So stage 2 stage 3, so instruction 2 will jump to which one? Now stage 2. At that time, when instruction 2 is jumping to stage 2, there is a blank in stage 1, so we can insert another instruction. Similarly, each and every instruction is jumping or complete their stages at that simultaneously. We can put number of instruction into the stages. Okay, so here 6 number of instruction is there, and it will take how many clock cycle? 10 clock cycles. How many clock cycle? 10 clock cycles. So first we will calculate the speed up ratio of a pipelining. What? We will calculate the speed up ratio of a pipelining. So how we can calculate the speed up ratio of a pipelining? Now speed up ratio equal to number of pipelining non-pipelining execution time by pipeline execution time. So speed up ratio equal to what? Non-pipeline execution time by pipeline execution time. So non-pipeline execution time is what? So in last video I told you what, suppose what, so look, so this is how many instruction is here? 3 instruction is here. Okay, so to execute a instruction we require how many times? Now tn time, and if we require to execute one instruction tn time, if there is 3 instructions, then how many time is we required? Now n into tn time. Yes or no? In non-pipeline, how many cycle we required? N into tn. So that's why we are writing here what, non-pipeline execution time equal to n into tn. And I told you here how many time is required to execute a, or how many cycles is required to execute a pipelining, execute 6 instruction in pipelining. Now k plus n minus 1. So pipeline execution time equal to what? K plus n minus 1. So speed up ratio equal to non-pipeline execution time by pipeline execution time. So n into tn by k plus n minus 1. But I told you, if n is greater than equal to k, then k plus n minus 1 approximately equal to n, or you can say similar to n. How it is happen? I told you, if there is number of phases are there, but we can't say that each instruction will be executed in different phase at same time. In last video I told you what, look, so if there is 3 stages, maybe first stage will be complete in 5 minutes, second stage can complete the task in 10 minutes, fourth stage will complete the 4 minutes. So that's why we can't say that each stage will be executed within a same time. Okay, so that's why we can say number of instruction, because the instruction may be huge in size, because the instruction size may be huge. That's why if the instruction size is greater than or equal to number phase, then we can say k plus n minus 1 also similar to n. Okay, so then speed up ratio equal to what, n into tn by n into tau. Okay, or we can write it what, tn by tau. So this is the speed up ratio, tn by tau. Okay, are you getting the equation details? Is it clear for you? If you doubt, you can ask me the question in my next video, before the next video. So next one is what, frequency. So frequency equal to what, 1 by tau. Next one is what, throughput. So before throughput, we just discuss about the pipeline efficiency. So how we can calculate the pipeline efficiency? Now the formula is what, ek equal to sk by k. K is nothing but number of phases. Okay, so already we know sk means what, the speed up ratio. Sk is what, nothing but speed up ratio. Speed up ratio equal to what, ntn by k plus n minus 1, or you can say ntn by n into tau. Okay, so same equation is written here, sk equal to ntn by k plus n minus tp. The tp you can say this is what, nothing but tp is what, tau. So tn, are you getting my tn? So tn is what, number of, or the total duration, or the total time to execute a instruction, and this is what, number of phases, and this is what, time required to execute one phase. How many phases are there? 5 phases is there. And if 1 minute required to complete a one phase, then how many time it require? Now 5 minute, k into tp. So k is what, 5, tp equal to to execute one instruction it required what, 1 minute. So 5 into 1 is 5 minutes. So sk equal to n into tn by k plus n minus tp, and that tp can be written as a tau. So next, n into k into tp. So tn equal to what, tn equal to k into tp. So I am writing here k equal to tn equal to k into tp, and k plus n minus 1 by tau. So now we can again we can write tp as a tau. I told you tp is also written as a tau. So n into k into tau by k plus n minus 1 into tau. So remove the, if we will divide this thing, then we will get that what, n into k by k plus n minus 1. So this is what your speed up ratio, n into k equal to k plus n minus 1. So pipeline efficiency ek equal to sk by k. Already we get it what, sk equal to n into k by k plus n minus 1. If we will put that value in here, then after equating these things, we will get what, n by k plus n minus 1. So this is the what, pipeline efficiency. So what is the efficiency of a pipeline? Now ek equal to sk by k. Get it? Or we can write ek equal to n by k plus n minus 1, where n is equal to what, number of instruction, and k is what, number of phases. Okay, this is the pipeline efficiency. So next one is what, throughput. So throughput is what, it will denoted as what, hk equal to n. So what do you mean by throughput? Now number of instruction executed per unit time. Number of execution executed per unit time is called what, throughput. So hk equal to n by k plus n minus 1 into tau. Equal to nf. Why I am writing nf here? Now already I told you 1 by tau equal to what, 1 by tau equal to frequency, 1 by tau equal to 1 frequency. So I can write here what, f equal to 1 by tau, so I can write here f. So n f by k plus n minus 1 is what? The throughput of a pipelining. The throughput of a pipelining. So n is what? Number of instruction, and f is what? Frequency, and frequency and k plus n minus 1 is what? K is what? Number of edges, and n is what? Number of instruction minus 1. So this is total execution time of a pipelining, and this is what? Number of instruction, and this is what? Frequency. I told you this is what called what? Frequency. This is called what? One frequency. Time duration, this is called what? One frequency. Okay, so this is all about the parameters about a, and this is the details structure of pipelining performance, or you can say these are the parameters through which we can measure the performance of a pipelining processors. These are the, so this is all about your lecture 2, pipelining architecture, and the design of a pipelining, and this is what? Performance of a pipelining processor, and this is what? Speed up ratio. So what is speed up ratio? Speed up ratio is equal to sk equal to n into tn by k plus n minus 1. So numerical question is asked in BPUT. Easily you can solve the problem. In next video I will prepare the numerical how you can solve the numerical problem using pipelining process, and how also you can calculate the throughput, speed up ratio, and pipelining efficiency. We will go for a problem. Okay, thank you.